In this episode, we're going to roll the calendar back to 1940. That's right, an 81-year-old shortwave plus AM radio. We're going to service it and get it working. Let's check it out. This is my latest acquisition. I was given this beautiful old 1940 Westinghouse radio when I was at work the other day. The customer had it, and I was just admiring it, saying, wow, that's a nice old radio. I collect radios. And he said, it was his grandfather's. He says, take it. I want it to go to a good home. So we're going to restore this. And what is significantly important about this radio, to me at least, this was a local radio. Now, I know that because of the preset buttons. Check out the preset buttons. CJOR 600. CBR, that would have been CBC. It's now CBU. Cairo radio is still in existence. That's out of Seattle. I think KJR is out of Seattle too. CKWX, that station's still around. That's our News 1130. And Como out of Seattle. So it had presets for the local stations. And the presets on this works just like the presets on old car radios. It actually physically moves the dial. You see it actually moves the tuning dial. See, just like spinning the dial. I don't know how to go about setting them, whether you pull them out to lock in the station or whatever, but one thing for sure, CKWX is at 1130 now, but they used to be on 9, I think it was 940 was their old frequency. CJOR is now 600. They used to be like 630 or 640. CBU is still at 690. Cairo, where were they? They were at 700. KJR and Como used to be way up at, I guess, 1290 or 1280. Anyway, this radio we're going to restore. And I also have the original manual. So this is a 1940 radio service manual. Westinghouse AC models. That's the radio there. They had basically three different cabinets. It has a tuning eye on here, and this was actually very similar to what my grandmother had. She had a Westinghouse console with a record player, and I've shown that record changer, the green one. I showed that in a prior video, but they tossed that out years and years and years ago. They gutted the radio and turned it into a liquor cabinet. Before I was into collecting radios, this was gone. This was tossed out, or it wasn't tossed out. I should say, it was converted into a liquor cabinet in the 1970s, and the only thing that remained was the record player, the actual turntable. They bought another little stereo to sit on top of it and plug the record player into that, and toss the rest of the unit out. Let's take a look at the back. That's the phono jack to plug a record player into. Stick the paper insulator in the middle. It's come loose. Antenna and ground, because a radio like this would have had an external, or could have had an external antenna. It does have an antenna wire here that's running around the inside of the cabinet. You can see this wire running around here. You see it does have an internal wire, so you don't need to connect it to an external antenna, but it does have an external antenna and a ground position. And we've got what, 1, 2, 3, 4, 5, 6, 7 tubes, I guess, on this one, and 6F6. Are these both the same? Are these both 6F6 tubes? Now this is going to be the audio output tubes. Oh, there's another tube hiding back here, which is almost unplugged from the chassis. I wonder if there's any tubes that are missing. This gives you an idea how obsolete these tubes are. Look at the old metal tubes, which have got glass inside them. The reason they're metal is that shields them. So this would be the oscillator and the mixer and IF. So you can have an oscillator and a mixer, preamp, probably one of these would probably be an audio preamp tube, probably that one. Haven't looked at the tube complements yet on it. Power transformer, it's got the big tuning eye over here. And this unit uses, oh, you can see we've got a bag of desiccant to keep things dry in the back here, keep moisture away. This unit here would have, or does have, a electromagnetic speaker, so it's not a permanent magnet speaker. There's a coil that is around the speaker core that operates to generate the electromagnetic field, and it's usually a humbucking coil as well. But the B plus from the rectifier over here is passed through that coil, and that is aiding in the reduction of hum, and it's used to magnetize the speaker. So this speaker plug on the back here, we'll undo this first. This will have the full B plus of 300 to 400 volts going to the speaker. So there'll be a usually it's a B plus into the speaker coil, a B plus back from the field winding that goes into the capacitor, and then it would be B plus on one of the pins, and then the other two that would go to the center tap of the audio output transformer, and then these two here would connect, or two of them would connect to the two plates for push-pull. So this is going to be a push-pull with the two output tubes. But before a unit like this can be plugged in, the first thing that needs to be done is we have to go through it and we have to change out any and all paper capacitors. It has to be done, because after 80 years, 81 years, they're not going to be any good. And the problem is, if you try to power something like this up, those capacitors will have become electrically leaky. And once they become electrically leaky, they will provide an overbias to the tube stage, which will cause red plating, burnout tubes, burnout transformers, and that's the last thing you want to do on something that's this old, is to power it up. So first things first, we're going to pull the chassis, and then I can go through and take inventory of all the caps, and then we'll start replacing them and doing anything else that needs to be done while the radio's apart. Not bad, eh? I've got the wiring diagram as over all the wires that are connected on the bottom of the chassis and where they go. The deep dive of the circuit description and how it operates and the going through the tubes and so forth, that's all going to be on the secondary release, which I'll be putting up on Patreon next. It won't be up first. I'll be releasing it in the next week or so. I'll have a much longer version. But this version is going to be the more condensed version, just to show the restoration and getting this unit functional. For those of you that want to see the more in-depth analysis of the circuit and operation and some things that are cut out of this one, join me for the Patreon release, say coming out in the next week or so. So first things first, we'll remove the knobs so that the chassis can be pulled. Disconnect the internal antenna. Screws and a combination of washers. We'll remove those, and then I can get the empty box out of the way and just work on the chassis. So let me remove the chassis. Once the 4 bolts that hold the chassis in place are removed, the entire chassis will just lift out. There's the chassis. The first thing I'm going to do is I'm going to just use some air to blow off all this dust. Now, I have to turn the chassis on its side or on over to service it. So if I'm going to turn it upside down, I'll certainly remove the tubes so that they won't get damaged. The transformers themselves should be able to hold up a portion of it, but just the way it's designed, these tubes are taller than the rest of the chassis, so I'd be better off to unplug the rectifier tubes and the output tube before I service it, just to put these away for safekeeping so that they don't get damaged. Remove the chassis screws. Looks like there's a couple of them that are missing. So this has obviously been serviced in the past. And that's not an original tube. These ones are Westinghouse. This is a GE tube, and this one's a Philco tube. So Good chance that those tubes were replaced at some point over the service life of this unit. So I don't know how long it was used. Made in 1940. It could have very well been used for 20 or more years before it was put into storage. So I don't know the history or how many hours this thing's got on it, but I would imagine it has a few. Oh, the same two screws are missing from this side, so maybe they didn't put those screws in at the factory. There's the guts. Now we can take the chassis out and remove the base. And look at all the caps I have to change in this. There's a couple, that's for sure. Get the base out of the way. What do we need to change on this one? These paper ones have got to go for sure. Resistors here. That big bugger's got to go. These mica caps sometimes go bad too, but definitely all these paper condensers here, they all have to be replaced. Looks like that one was replaced at some point. Wax molded paper, solar. You can see somebody soldered that one down. You need a good size iron to solder down to the chassis. That's been redone too. And here's precisely why this one broke right off. This one wasn't even soldered down properly. It went to that pin there, but here's precisely why you need to change these out. Watch the meter. Watch the meter. A capacitor should go to infinite resistance as it charges up, which it is. Thing is, this is not connected to anything, so there's nothing to drain this charge. If I release the meter and reconnect it, it should stay in overload. But it didn't, you see? There's some leakage. And at high voltage, that would likely be breaking down. I don't have a breakdown tester here. I can just test for physical leakage, but this one here obviously has some internal leakage, because if there was no internal leakage, that capacity would stay. It would hold the charge, but the charge is dissipating because, as you can see, it only went down to 30 odd meg ohms, but still. These paper caps all need to be changed. These red ones need to be changed too, you see? So all these red caps, all these paper caps, even some of these mica ones here probably should be. Some of them are in critical, some of them are in critical circuits, others are not. But they'll certainly affect the tuning of the radio for sure. The ones that aren't in critical circuits, but the ones in the plate circuits most certainly have to be changed out, because those are the ones that are going to cause a catastrophic failure. So I'm just going to take inventory, and we'll get some caps, and then we'll pick this up once I have them. Looks like this one was changed before. That's probably why it wasn't soldered down right, was somebody didn't tack it down properly. This is a 0.02, but according to the manual, it's supposed to be a 0.01. And there it is there, C47. 0.01 microfarad, 500 volts goes into the grid from the plate. It's a coupling capacitor, so that is a critical part. If that fails, it's going to burn up that tube and probably the output transformer as well. So see, these are some of the ones, the critical tubes that actually have to be replaced, because if not, we're going to end up with some long-term serious problems. So I'm going to start replacing some of these caps here that are bad, that need to be replaced. I'll start out with the ones that I have. This one's a 0.02. I have a 0.015. And the original one in the manual showed it as being a 0.01, so somebody's obviously changed this in the past, and I'm going to go back down to a size that was closer to what the original one was. Looks like somebody just clipped this out, and like they clipped it and just soldered it right there. I gotta change out this one down here. So that one comes out from that side, and this other side goes over here to this output tube. What size is this one? Numbers are pretty much worn off of this one. This is one of those times where I forgot the camera was recording. I thought it was not recording now, and I'm checking the schematic and the wiring diagram, just seeing where the parts go. Point 1, 600 volts. It's not going to quite reach to that one, but I can bring it around and tie it down to where these other resistors go. And capacitors go down to the ground here. Just take it around and tie it down to this one. These ones were what we knew as black beauties. Because you see, all they were inside was they were just the same cap. They were the same wax paper. Exactly the same thing happened to these ones that happened to the regular paper caps. They were just encapsulated, and that's the same as this one here, right? That's what's under there. Underneath that is just this. It's like an epoxy or a bake. Not even epoxy. It was Bakelite. They hadn't invented epoxy back then, and it's brittle. It will break. And you can see here, this is what's inside these. These were called black beauties back in the days. Okay, there were other words used to describe them, but we'll stick with black beauties. See, this is the paper and the foil. So this is what's inside all these caps like this. It's just two electric plates that are separated by a paper, a wax. And the paper itself, the acid in the paper basically turns them into a resistor. You can see here's the plates. If I separate the plates, you see, they're just the metal plates. They're separated by this paper, and the paper itself is what breaks down over the years, and it allows electrical current to leak through the paper from one plate to the other. So instead of these storing a charge, they pass current, and their job is to block the flow of DC. So any of these paper caps, whether they're encapsulated in a Bakelite, which is an early form of a type of plastic, whether they're Bakelite or whether they're just these type here, right? These are just the wax paper. I can open these up and they're exactly the same. Cut off the paper. they're exactly the same inside. Right, here we go. Right, exactly the same. But these all have to be replaced. These red ones are no different. They're exactly the same. Maybe not quite the same material, but they'll still break the same way. If I squeeze it. Now this is a newer type, but still, they're all the same inside. So we call these ones little redneck bastards. To cut this with, because they blew up just the same. We take out horizontal output tubes, damper tubes. This was a little bit heavier, but still, as you can see, the construction is exactly the same. There's still a paper-based capacitor inside, and it's the paper that breaks down. So these red ones and the black beauties, they all have to be replaced. Even a lot of these other ones here are very similar. These ones are mica. The mica ones typically aren't as problematic as the paper ones. But these ones here that have the paper inside them, this is the problem. Right, and these are all paper based. You can see it there, right? There's the paper. So that's why we change them, because the paper goes bad and they go conductive. And once they go conductive, end up burning up tubes and burning up coils and transformers. So all of these, like all these ones here, have to be changed. That one's got to be changed. This one's got to be changed up here. That's got to be changed. I don't have that. I got to get that one. That one's got to be changed. That one's got to be changed. These ones over here have to be changed. Some of them aren't as critical as others because if they're not in a plate circuit, they're not handling super high voltages, then they're not as problematic. If it's just in the signal switching, if they go bad, they detune their receiver basically. But for good measure, they should still probably be changed out. Oops. That one I put in the wrong way. Now I have identified, I haven't done it on camera, but I've checked with my scope these new caps and identified which is the outside foil, which we want to go to the low impedance side. In this case, it's the ground. I haven't marked all these ones, but I have checked them, and I've identified them using my scope. And I won't go through that on this particular video because I've gone through that before, but there are plenty of videos out there if you want to identify or want to know how to identify the outside foil. And basically, what the outside foil is, and it's not as much of an issue on these Mylar caps as it was on the older ones, just because of the physical size of the foil in them. But basically, if we remember that capacitor that I took apart when I unwrapped the foil, well, there will be one the outside plate basically is the one that's on the outside, that is closest to the outside, and it will end up being the plate on the actual outside wrap, and that's connected to, in this case it's marked outside foil, it's got a black mark on it, that's connected to this terminal. The inner of the two plates that are wound together connected to this one. And the reason you connect the outside foil to like your grounding terminal or your low impedance side is just so that influences from the outside world won't cause interference. It's a much more serious problem when you've got a capacitor like this, which has got a large surface area, than it is on a small one like this. It's still an issue because you still have an outside plate versus an inside. And I've shown it before how to do it. There's other videos on the net, including one fellow that even actually built a little machine that he'd hook it up to the leads, and it would tell him, or would go to his scope, and it would switch them back and forth automatically so that he could see which one was the outside lead. And basically you just hook your scope probe across it, and one will have more noise than the other, and the one that has more noise is the one that's connected. Like when you put your scope across your two plates, for example, connect your ground to one side, connect your probe to the other, and look at the interference that's being received, the RF, so forth, that's being picked up out of the air, and then reverse the two, and one side will be higher than the other. Well, the one that is got the highest reception of unwanted noise is the outside plate, or the outside shield, or whatever. I've done it already on these caps here. Some of them you'll see a black mark on because I've gone through and I've marked some of them with a Sharpie. Other ones I haven't, just because I've tested them all in the bag and found that they're all the same. Basically, if I haven't marked it with a mark on the right side, it's the with respect to the label, it's the left side is the outside plate. But the odd time you'll get ones where it's on the right side, and it's just due to labeling. The capacitor came out of the machine and it got flipped around while it was being manufactured, or some brands the outside foil will be on the right side, and when I've identified them, I've marked it. So some you'll see with a black mark, I'll just put a little black dot on it, or a little black mark, so that I know what it is. Others I don't, and if I don't, it's because I've tested them and they're on the left side. So it's just for my own reference. So that's why I'm not showing it. I could go through that again if I wanted to show you guys how it works. I've done it on several other radios. If you watch some of my other vintage radios, I've gone through how to do that. And as I say, there are other videos out there on YouTube where the other guy goes into very good detail on how to identify it and why it's important. And it was more of an issue with these large physical size caps than the new ones. But if you are trying to make the radio as absolutely sensitive as you possibly can, and you're trying to restore this thing to the absolute best quality, best sensitivity that you'll ever get, then yes, it will make a difference. And I try to keep them going in the way that the others came out for that reason. As far as sensitivity goes, for me, I'm not going to tune this up. I'm not going to put on function generators and RF generators and sweep generators and stuff and tweak the IF. I'm just going to replace the capacitors. This is my radio, and as I say, it's more for show than anything else. As I've explained before, I don't power these things up and listen to them on a daily basis. You know, if it gets used, you know, one or 2 hours a year, I will be really surprised. It's more to show it off. I have a number of them on display, and you know, if a friend comes over or something, says, "Oh, nice old radio, does it work?" Yeah, you want to take a listen to it, and we'll plug it in, we'll hook it up to an antenna, and we'll tune in WWV or tune it around the broadcast band, and take a listen to it, and that's about it. So as long as it puts out sound when I'm done, and it receives the local stations, then I'm happy. This is restoration basically I'm doing. It's just to preserve the tubes and the transformers and coils. This has to be done, right? So, and that's why I'm also not going with the highest quality capacitors. If I wanted to, I could go and order some and get some really high-end capacitors and pay $5 or $6 a piece for them. But you know, that's completely unnecessary for what's going to happen with the radio when I'm done. I want it to work, but if it doesn't work to how it came out of the factory, I'm not too concerned, because I'm not going to be using it for that. Right? I have other radios. If I want to listen on the shortwave band and listen to international broadcasts, which are pretty much a thing of the past these days, unless you want to listen to the God channel, you know, there's not a lot on shortwave. All the big broadcasts I used to listen to as a kid, I used to listen to Radio Australia, Radio Havana, Cuba, you know, and all the others around the world. BBC, I used to listen to BBC, Radio Australia, Havana, you know, Cuba. Used to listen to all the interesting stuff, but for the most part, they're all gone. And if you want to listen to those stations, well, you do it over the internet like everybody else. So this is just kind of for the nostalgia of fixing this old beast up. Now, working on a chassis like this is where you could certainly use one of those big 150 watt soldering guns to solder right down to the chassis. This little 60 watt iron I have doesn't have anywhere near enough power to do that. Now, so this is the main multi-filter or multi-stage filter cap here, and I'm going to be putting an electrolytic on the bottom here, on the bottom of the chassis, just to replace this one here, because this being a multi-stage, it could be bad. It may not be. It may just reform. I could try it without replacing this cap and see if it works. The only thing is, the way that the unit is wired, if we look at the schematic, well, one side of it's right off of the cathode of the rectifier tube, you see, but the other side, so it goes into the first 20 microfarad, first stage, and then the second stage is connected to the return from the speaker field, which is the another 400 volt rating. And if this cap were to short, we'd be drawing all the current through that speaker field coil, which could burn it out. So that's the main reason we changed this one here. It's made up of 4 capacitors. One of them's just a 20 microfarad at 25 volt, which is for the grid bias for the outputs, and the others are 450 volts. So we'll change these out. I've got a few of them here. We'll change these ones out. I'll just cut the tabs off and solder the wires in directly that go to the corresponding stages, just because it may be okay, but I don't want to take a chance that it could pop this the field coil here. And that's what would, if one of these stages was shorted, if the primary stage here was shorted, well, you could burn up the tube or the power transformer. If the secondary one of the secondary capacitors was bad, not only could it affect the power transformer and the rectifier tube, but it also could damage the speaker. So these may be okay, but just because of the age, I'm going to change them out. So this one here, this orange colored or yellow colored wire, I guess it's orange. This is the first stage. I'll do the same for the other one on the other side. In case you're wondering, this is the 25 volt cap. These ones here are all the 400 volter sides to it. See, doing it this way, it keeps the radio looking original. I know some of the guys that restore, they'll actually pull the old can out and they'll open it up and they'll gut it, and then they'll throw 3 caps inside the unit itself, and that's another way of doing it. and then they'll put the old one back in. Like they'll open it up, remove the contents, and then put it back in the chassis. And I'd say that's one way of doing it. Okay, for one side of the filter, I just grounded it along with this other bypass cap here, which I tacked onto the original ground. We can just tuck this one up out of the way out here, so that wire's not going to touch anything. The other filter that went over here, I'm going to take this cap that I put the heat shrink tubing on, and I'm going to bring this one down here, and I'm just going to connect this one up to the spare ground tab that's there, and that'll get this one out of the way as well. And then just route the wire back up out of the way and ground that one right there. At least my soldering iron's got enough power to heat up these tabs and get a good connection. That's not a problem, but trying to solder it down to the chassis would certainly be problematic. So there, I've got two 22 microfarad. The original was a 20, I think it was a 20 and a, what was the original? The original was a 20. This one was a 20. I've replaced it with a 22. That should be okay. That was a 15. I've also replaced it with a 22. And then the third one, this one here, is a 5 microfarad at 300 volts. I'll put a couple of 3.3s. Well, even one 3.3 is probably enough. Two of them will give me 6.6, and that's probably more than enough. And then this one here was the low voltage one. But we'll replace this next one here. And I can just ground that one probably right to this tab right there beside it. It shouldn't be a problem. Just parallel these two. There we go. That'll be fine. This is the low voltage side of the can here. Again, this is the small cap. And once again, I'll just put some heat shrink tubing on here, just to make things a little more safe. Not that the cap with rated at 25 volts probably won't have more than about 10 volts on it, but we'll do it just for keep things constant here. The ones that are easier to get to, like on the volume control and the tone control and stuff, even though these ones aren't real critical as far as causing damage to the radio goes. These ones here are If you're wondering what I'm doing, you'll see in a second. This will melt the old wax so we can read the value of the old cap. That's a .005. For those of you that can't see the number, if the wax or if the capacitor is so dirty and the wax is so dirty, just throw some heat on it. It'll become very clear. .005, so 0047 is what I'll be putting in there. At 500 volts, well, mine's 630, so we'll be okay. This red one here needs to go as well. These ones do fail. And this one's in the plate circuit for the tone, so it's a blocking cap, so it's a .01. Got another one here, much smaller, of course. And I'm just going to cut it back here and join it onto the wire because I need the length of wire to connect it. Otherwise it's not going to reach. It's got to reach back over to here and connect along with this other one. So I'm just going to trim this one out and we'll join the wire and then just dress it so that it's not going to touch anything. This one has been replaced before. Looks like it was replaced when this was serviced at some point in the past. Comes up to this coil here. If I can get at it. I'll probably put this one in here like this. Since it's smaller, I can squeeze this one in a little easier than the other one for sure. Now we can go in there just like that. The real hard ones are going to be these ones here. There's two of them here that are Look like it'd be almost impossible to get. Just gonna cut this other one out of the way for now, just so I can see where these other ones go. Jeez. Where does the other end of that cap go? It's a wire that comes way down to here. Actually, it looked harder to get to, but it might not be so bad. The other end of the wire comes down right to this lug here, so that one might not be as bad as I first thought, actually. It looked ugly to begin with, but it's looking less ugly now, because that's where it goes, I think. These old radios are always lots of fun to work with, and people say that the old stuff was simpler. Yeah, I've never worked on some of these old radios, and the German ones were even worse. The Grundigs, ugly radios to work on. When you start, well, the next cap is going to be the one that was the most difficult. It's the one just under my finger there on my left hand. That one was a challenge, even for me. I didn't want to disassemble the switch to get at it, but it solders down to one of the tube sockets that's basically directly below the shaft of the switch. It was almost impossible to reach. Okay, that one's done. This other one here may be tougher to get to. There's another one here that's buried. These are the two hardest ones, I think, to get to. Another one over here, but I think this one should be relatively easy to get to. But there's one right here on the back side of this switch. I can't even see where the other side of the wire goes. It's all buried down in here with all these wires that go to the different coils. You know, the different taps, so I really want to be careful when I do this one, because one wrong move of the iron and it's going to destroy the coil, and then you got a real problem. I'll disconnect this wire first. I'm documenting this so I know where things go. I'll disconnect this wire from this lug of the switch, just so it's out of the way, so it doesn't get damaged, and we'll clip this side of the cap off and see where the other side goes. Where does it go? Yikes. Goes to one of the tubes as well, so this is going to be probably a critical one. It's just impossible to see where it actually connects from my vantage point anyway. I was able to clip it out. The fun part is going to be putting a new one in. It's another 0.05, which I don't have, so I'm going to go sub it to the next size up. But it's connected way down inside here. I may be able to get there if I really am careful. Get some solder on the end of this part. I'm just going to have to basically tack it in there with the iron into the tube socket, but if I can get in there, then I should be able to do it very carefully. Wish me luck, because I'm going to need it on this one, that's for sure. See if I can get the part in there and Just hold it in place and get the iron in there to heat it up. I can see the pin. It's right in behind this shaft. I'm going to get some solder in there if I can first. Just to, you guys probably won't be able to see what I'm doing because it's just buried so deep inside this thing. Like just getting the light in there to see what I'm doing is a challenge. Bear in mind this is nail biting time. I've got a 700-degree iron in amongst enamel wires and coils. On the actual tube socket. If I touch that coil, now I'll ruin that coil. I'll ruin those wires. On this radio, this was the most difficult part to access. But this cap had to be replaced. It was on the plate of one of the tubes, and it's a blocking cap, so it was one that had to be replaced. There was no question. That one had to go. Yet is proving to be a little more of a challenge. The proper way to do this would be to take the switch apart, but that's not going to happen. No way I'm taking that switch apart on this thing. I have a hard time getting it back together. I'm trying to tack it onto the lead that I cut off from the old cap. That's what I'm trying to get to, is the lead from the old cap. I've got solder on it now, so hopefully I can get the new part in there and just get it to stick. I won't be able to twist it or anything on this. It's just too deep inside that set to do it. I'm just hoping that I can get enough solder on the actual the wire here that I can stick them together and make a good connection. I might have it. I might have it. I think I got it. That was a fun one, that one. That went to that lead there. And then the other wire went back to the other side of the switch, so that went to this one right there. Wire went back to this one. I think that's the way it was, wasn't it? Another 0.01 goes from here up to there, across this coil here. So we'll take this one out. Use the same material to insulate it. And that one will reach quite nicely right to that switch. That one. And where's the other side go to this? Goes down to a tube, I believe. You'd think the wire would break off, but the wire is actually broken off internal. The end of this cap came right off. Gives you an idea how bad these were. Like the end of that cap came right off. That's why these all have to be changed. Because there would have been fireworks had I fired this up. That's right on one of the tubes too, right? Probably a plate. But yeah, you see? It just came right apart. What is this? This is a 0.05. Let's get that one and replace that one. This is a 0.02. A 0.018 is going to have to be good enough because it's all that I have. It's just going to a ground wire anyway, right? It's the antenna ground. So it's going to have to be what's going in because that's all I've got. They didn't have any 0.022s at the store. The closest they had was a 0.018. So that is going to have to do for this. I think it shouldn't be a problem. It's just a ground for the one of the coils in here. Shouldn't make too much of a difference going from a 0.02 to a 0.018. We're talking 2/100ths of a microfarad. I don't think that'll be too much of an issue. What is more of an issue here is will it reach? Oh, it's just going to reach. Excellent. I have to bend the leads a bit there. I don't like to do that on these because you can break the seal if you're not careful, but I didn't bend it that far. Okay, I think I've got all the paper caps replaced and the electrolytics replaced on this unit now. I'm going to go get the rest of the radio. We'll put the bottom on the chassis, we'll put it back in the cabinet and turn it on and see whether it makes any noise. One thing I did neglect to get, which I had meant to, but I totally forgot, and that was light bulbs. 6-volt bayonet mount light bulbs. I'm sure they're burned out. That one for sure, it's black. That one might work. But I was rushed when I got down there. Every time I go to that the parts store, you're always rushed. Like they rush you out the door. Like they don't want you there. You walk in there, what can I get for you? You know, what do you need? And they're grabbing all your parts for you. And it's almost like they say they want to get you out the door to get on to the next customer. You don't go in there to chit chat, that's for sure. And you go in there knowing what you have to have, because they want to get you in and out of that store as fast as possible. And when that happens, you always forget something, right? I totally forgot about the light bulbs. Hold it in place. I'm gonna finger tighten these in for now. I just want to hear if this thing makes noise. If it makes noise, I'm happy. Antenna screw back in. This definitely will go onto the dim bulb tester, just to make sure there's no short circuits or anything, so it'll be plugged into the 100-watt bulb, which will of course limit the voltage, but it should still work. I don't see any serious defects with the power cord, although it is ancient, so at some point I'll replace the cord, but for today we're going to test it with this original cord. So we're going to try this together. Okay, got the power on to the dim bulb. I see a little bit of glow. Are we going to get any sound? Let's turn up the volume. I don't see any excessive current. The dim bulb is glowing dimly. Are we going to hear anything? Let's see if any tubes are warming up back here. I see some tubes warming up. Yeah, I see light on the tubes. One of the panel lights is working too. Knock down my MP3 player. Actually, it looks like both the panel lights are working, which is amazing. Oh, wait a minute! I hear something. Okay, so we're running at too low a voltage. So, we know it's going to put out some sound. Let's give it full power and see what happens. Turn down some of the lights in here so that we can appreciate the display that lights up on this. And it does light. Both lamps are working, both sides. Controls need to be cleaned. Oh well, I'll do that again at some other time.
Back in the 60s, 70s, or will it take the consulting approach and continue the road of it being an inclusive member of the global community?
So when you hear something like Beijing intending to set up a new stock exchange, does that give you the sense that maybe the focus is going to be a little bit more inward, at least in the near term?
Well, I think that President Xi...
Remember, I don't have much of an antenna on this. I just got that piece of wire that's...
to create jobs in his...
I put my hand near there.
Small medium-sized businesses. So he's trying to funnel as much money as possible to try to spur the...
Beautiful.
Jonas is an aviator. He was cool. He's really women. But he was a weird dude at his quirks. Oh, we miss him.
Co-founders, as she was asked about the protest and which one.
AM is really noisy here due to all the electronics that's around me here. Like, it's bad. In the house here, it's really bad.
Reports of a pedestrian hit over Maple Ridge. 207 at 118th. Any update?
And it's got pretty good volume.
Let us know pound 730. You're listening to AM 730. Hi, it's Janice.
Got a bass and a treble control.
Once you're all caught up on traffic, head on over to the 980 CKNW. It's more than news, it's context, perspective.
I think you'll learn about the candidates.
Of course, that station's going to come in good. Let's try my test channel. Switch needs to be cleaned for sure. Now for shortwave, I definitely will need an antenna on it. I don't expect to pick up anything whatsoever. It's got a phono input on the back too. Could plug some music into that. Probably a magnetic cartridge input though, more than likely. Somebody has a plasma TV turned on. I can hear it. Just tearing up the AM band like you wouldn't believe. But
Eastbound as well, also expected. Over to the Pacific Ridge, King George McBride Boulevard doing fine. Brunette westbound in front of Columbia still a touch busy. Cleanup stages of the crash on Brunette westbound at East Columbia right lane should still be blocked off. The Port Main Bridge is.
I'm just putting my hand near the antenna, right?
All right, small delays.
Because it's just a piece of wire running around the inside of the cabinet.
And Highway 131
Obviously,
eastbound starts to get a lot of fun after 2:32, which is to say it's not fun at all. It's where the congestion.
if I put an external antenna on this thing, it would pull everything in.
4 more eastbound delays from Mount Lehman all the way up to about Sumas, and then eastbound opens up after that. Westbound starts to get.
It's not going to be forever. Also, at the end of the day,
That's my transmitter humming, by the way. It does it on everything. I don't have a ground on it. If I turn on this receiver, you'll hear the same hum. Quite a difference. So here's my Pioneer receiver on AM.
are working to suppress raging wildfire.
Biden's also claiming help for the victims of Hurricane Ida. Amazon Prime Video tomorrow. One of the big changes is the
2025, the gains on May largely coming from energy stocks. The price of oil was up 2%. Well, basketball management says CN Rail should drop its attempt to buy Kansas City Southern. The investment service is a CN Rail investor, but says after regulators blocked the company's offer, they no longer have a chance, though CP Rail might.
It would be
It's working great. Now you have to remember, the tubes are obviously tired on this unit because it's old. The Magic Eye is glowing. It's not very bright. That will give you an indication if you're tuning.
10 minutes for the crossings as well.
You see?
Fine for the wait times anytime.
Normally they're a lot brighter than that, but this tube obviously is getting weak, as I'm sure the other tubes are too. After all, this thing is 81 years old, and most of these tubes are original tubes. Keep that in mind. There's a couple of them that have been changed, but the rest of the tubes in here, they're original. But look at that, the display lights up. The Magic Eye is working. You can see it, it's just not very bright. That's how it works. Now normally these things were a lot brighter than this, but again, it's the tube itself is going to be getting weak, and that's just unfortunate. But these ones here, they did fail relatively soon. It was a tube that was consumed quite a bit because it was basically putting out full emission to light this thing up, right? So they always were a tube that did fail quite regularly and sooner than other tubes. But oh, there you go. There's that strong signal.
The jobs report.
See, what happens on this is the phosphorus gets weak, right? So this signal being really strong, because it's, I mean, the transmitter, it's only 400 milliwatts, but the transmitter is literally sitting in the same room as me. So this is going to be the strongest signal this thing's probably ever going to see. And of course, there's a little bit more emission on that phosphorus because normally the whole tube lights up green, right? And it's just that the ends get closer together for the stronger signal. So normally this tube would light up bright green, but because the whole entire tube is always lighting up bright green, the phosphorus gets weak. So now you see what I mean, right? I'm tuning in a real strong signal and the ends are lighting up just because, well, it's not burned as much as the rest of it. Look at that, hey, cool. Anyway, hey, I'm very happy with this score. I'd like to thank the client that gave this to me. I'm not going to mention their name, but anyway, I'll be sending them an email, and they wanted to see the restoration work, so I'm going to send them an email and let them know, hey, I got the old radio running. As you can hear, it sounds great. And we've preserved another piece of radio history. We've preserved another one. Goes into my collection, and hopefully it'll be in my collection for a while, and hopefully when I'm gone I'll pass it off to my kids, which probably will say, what do I want an old antique radio for? I say, because they're cool. So if you're watching this on the free channel, and you know who you guys are, there's a longer version of this radio. I've condensed it down just for time, but I will be releasing a longer version showing more of the restoration, more of the changing of parts and stuff. There'll be a little bit longer version that will be released for my patrons to watch this old radio get restored. I'll let you guys see it, look around the back, and then we'll close this video off. And there's the look around the back. All the tubes glowing away here. Original. I think that's a Westinghouse too. That's an original. Is that a Westinghouse? Yeah. So original, more likely. At least they're Westinghouse. Oh, those are GE. So those may not be. Those may have been replaced. But these ones for sure. I'm sure these ones are original. Impossible to find these. That's for sure. These ones. I have some. I have a few of different values, but those ones are pretty much obsolete. But yeah, there it is. So I'm going to clean the switches on this and finish the reassembly.